All right, so this is lesson 1-1. This is literally baby steps geometry style. So understand some of this, you're going to be like, is this really high school level math? But there's a few things I need you to do first. Everybody raise your right hand. Repeat after me. I'm not in algebra class. Mrs. Gregerson isn't my algebra teacher. She's my geometry teacher. Thank you. I do not look like your teacher. I am not your teacher from last year. You're doing it my way. Got it? Okay. Now, the reason why I'm doing this is because everything in your fiber and your being, your head's going to hurt when you're done with this. It's a different way of thinking. We will always do algebra. We always apply algebra in here, but it's going to feel like a different class. You're going to have to memorize definitions. You're going to have to memorize theorems word for word. You're going to have to do geometry, then algebra together. It's not going to be like, here's a problem, solve, move on. Here's a problem. It doesn't work that way anymore. So it's going to feel like a combination of a math class and like an English vocab class. So I need you to trust me. It's going to take a little while to switch over, okay? But you'll get there, so give yourself a little bit of a break. You're going to be fine. And give me a little bit of a break because it's not algebra. But you'll be fine. Now, what's so cool about geometry? Well, geometry was created thousands of years ago by Euclid. He was a famous philosopher, by the way, science and math and blame philosophers for it. He had a way of writing basically the first math textbook, and he based it off of what's called Euclidean geometry, which is what we study. There's thousands and thousands of geometries out there. We're studying one. I call it the one that matters, okay? The one that works. And he had a way of doing this. He started with what's called undefined terms, stuff you can't define but you can do. Then he defines terms based off of those. And then we have postulates. And then we have theorems. So let me explain to you like what an undefined term is. When I say blue, do you all know what I'm talking about? Without using the word color, explain blue to me. Don't go science. When you're 1, you did not have the science of what blue is. Did you just know what blue was? It wasn't really defined. You just knew it. But when I say blue jeans, do you know exactly what I'm talking about now? Because I use the word blue to describe jeans. Jeans we can define, but like blue, we now can put it, oh, it makes sense. Like whoever said blue is blue, I don't know. That's how they defined it. So that's how it works. So undefined is like you can't define it, it's just there. It's just, yep, that's what it is. And then defined terms is we use those terms to describe it. Postulates are rules. And so you're going to get your first rules. And then theorems are rules based off of other postulates, theorems, and rules. So they're provable. Theorems are always provable. Postulates aren't. They're just true facts. We'll talk about it as we go. All right, undefined terms. So, okay, I'm kind of a hypocrite. I just told you they're undefinable, but I'm going to define them for you guys, okay? So we're going to talk about this. The very beginning. Everything in geometry is based off of this. It's based off of a point, okay? What is a point? Here it is. It names a location and has no size. A point names a location and has no size. That's very helpful, isn't it? It's just there. And here's the cool part, though. We represent it by a dot. Because in our world, it's just a location. It has no size. We just know it's there somewhere. Is a point. So then there's no depth, there's no width, there's no height. It's just there. Isn't that weird? But think about it. When you look at a map, how do you define where you're going? You go to where it's the what? The point on the map. So it's really the idea of location. So we have those. So we use dots to represent those. Not really exciting. So as you see in the diagram over here, do I have 5 points drawn? Yeah. And what type of letters are right next to them? Lowercase or capital? Capital. Capital letters always represent points. Think about on that homework last night, when we had the L and M for finding the distance formula. Was it a capital L and a capital M? Because those are points that we were talking about. So that's where the notation comes from. So for instance, you'd say notation, you have to tell me what it is. You use initials, please. Go PT, and you'd say point A. Because the moment I say point A, does your eye take you right over there to A? It does, doesn't it? The moment I see point A, you're like, oh yeah, I know what that is. And if I said point D, do you all know exactly where to look? That's how easy it is. We need those labels. But here's the big thing. It has to be a capital letter. No capital letter, you're not communicating it clearly. And geometry class, a big part of it is learning to communicate math right. So it has to be a capital letter. Now, space is actually a defined term because I use undefined terms. When I say space, what is it goes into your guys' head? Outer space, right? Which is like everything. Anyone go Star Wars, right? You know Star Wars, it's everything. Okay, that's what points are, okay? In geometry world, everything is just made up of points. So don't feel like, okay, this is not Bible, real world, okay? This is geometry world, okay? That means in this room, you're breathing points, you are points, you're the force, people, okay? You're just everything, you're just points. Think of the smallest thing you can absolutely think of and make it smaller and then make everything out of that. That's points. So all of it together creates space. So that gives us all the dimensions and everything's included. So space are all points, and I abbreviate a lot, right? All points that exist. It's everything. So anything that we have geometry-wise, it will always be in space because it's all included. Now, there is no notation for that, and there is no diagram for it because can you draw everything? Are you with me? You see how that doesn't work? So space is like the force, okay? Everything. All right, a line. If I ask you to draw a line, could you all draw it for me? Okay, draw it. Over here in the diagram, just draw a line. What's so special about your line? You all knew what it was, right? Did any of yours curve? No. Well, that's what you were sloppy. It wasn't because you didn't know what a line was. Yeah. No, you drew it straight, right? Now, here's the difference. Some of you didn't do this. What did I put on mine? You know what the arrows say? The line goes what? Forever. But you all knew it was straight. You didn't know that. I didn't even define it for you, and you all knew a line was straight. And you knew it goes on for what? Forever. Isn't that cool? There's lines going everywhere forever. So let's try to define it a little bit. What's a line? It is a straight, and this sound does not make sense probably, a straight path that has no thickness and goes on forever. It doesn't ever stop. So, okay, Star Wars example, the closest thing to a line that I can give you is the double-sided lightsaber, okay? So just imagine that laser keeps going on forever, both directions. And no matter which way, like right now, if you have it, those of you that active imaginations, you can go there with me, there's lines going every direction right now. You're sitting in just a bunch of lines. Those of you who don't have active imagination, just trust me, there's lines everywhere, okay? They just go everywhere. So, because as long as I connect points, I have lines. But lines are really just a set of points that go on forever. I just take a point, I'm like, I'm going to go in the opposite directions forever and ever and ever. So we have to label it, okay? So when you talk about a line, you need at least 2 points. And so points are labeled with the type of letter, capital letter, right? So you need 2 points. You can use any 2 points on it. So any 2 points. Or if it doesn't have any 2 points, they will have sometimes like a lowercase letter. It's like italicized or cursive off to the side. And then use a lowercase letter at the end of it. And they will call it that. So like in this case, that would be an L. Lowercase letter would be used. Okay, let me change this so I can use the correct notation here for you. Blue looks like a good color. So what's that correct notation? Well, here's how geometry teachers are. We're not original. When I name a line, I would name it either line, X, Y, and guess what I'd put over my X and Y? A line. Isn't that brilliant? A line is used a line symbol. But your X and Y go right next to each other, and it's a capital. But here's the other thing. You can go the other way. It's line YX. Both of those are correct ways of naming that line. Or you have to write it out. Or you write out line L. All three of those will signify that line. They will signify that line. All right, do you guys remember this from before, right? You've had this probably in math before. You guys remember this? Okay, give me head nods. I need something, people. If not, hopefully it's not going to be too hard, because you're going to have to be able to draw lines, label lines, and be able to tell me what they are by looking at them. All right, then we have what's called a plane. And most of you, when if I said this, it makes sense to you. A plane is a flat surface. It's supposed to be an L there. All right, so it's a flat surface that has no thickness and also extends forever. Now, basically, is the top of your desk a flat surface? The only problem is it doesn't extend forever. Use your imagination. Guess what it just does? Extends forever. Oh no, it just went through you. Oh no, my plane just hit me. That's okay, you're just a bunch of points. You know, just let it get back in because it just keeps on going. Think about that whiteboard. Is it really just a bunch of points that are flat? And can you just imagine it keeps going through and it just keeps growing and growing. It goes down through the ground, it goes through China, you know, all that good stuff. And then it goes up, you know, to the heavens forever and ever. It never bends, it's always flat. Just goes forever and ever. All right, I know that's hard because some of you are like concrete, like, I don't like imagining it going forever, but that's what it does. So in your mind, all right, you guys agree with me that this assignment book is flat, right? Can it be going this way and this way? Can it go this way and have a plane going this way and this way? Can it go in any direction? So planes are everywhere, just like lines. They go everywhere. Now, how do you name it, okay? When you name this, to use notation, you use at least 3 points or a single capital letter. All right, now, a lot of things when we do with planes, because we're trying to draw a plane on a plane, a piece of paper is just a plane. We use parallelograms, you know, the cutting off this side quadrilateral, right? It leans. We draw that to represent a plane. So in your mind, that little green plane is supposed to be kind of coming out at you a little bit. But notice I have 3 points there. So when you name it, you could have here, you'd have plane ABC. Now, it doesn't matter which way you name those letters. So you could go BAC, etc. Could I go plane cab, plane CAB? Yes. You just have to name 3 points. Now, my rule is you want to name 3 points that are not all in a straight line, and I'll explain a little bit more why later. But you could also use, in this case, because of this little R, notice there's no point next to it, it's like kind of italicized, you could also call that plane R. But here's the thing in common for all of this notation. What's the one word in front every single time? Plane. You have to write the word plane out or you're not telling me it's a plane. You don't need to have commas between there or anything like that. As long as you have the plane, you're going to be good. All right. Those are your undefined terms. Do you think you guys can go with those? All right. Let's have a little bit more fun and let's talk about, it's going to drive me nuts. So here, this is the cool thing about OneNote I'm going to show you guys. I can lasso this and then I can move it to where I want. You can do that with your homework and stuff too. It makes life so pretty. All right, anyway, those of you who are perfectionists, that's going to be one of your favorite tools. Now, collinear points, guys, those of you who had roots, what does co mean? I told you it's geometry, it's English class. Co means what? Together. What does linear mean? A line, straight, right? Together in a line. So collinear points are points where? On the same line, okay? So collinear points are points. Let me not have a highlighter on though when I'm doing this one. Here we go. Points which lie on the same line. All right, so do you guys see this lovely line right here? Okay, can I call that line T? Do you see the lowercase t here? So that's line T. I need collinear points. So here's a few things you want to do. When you name collinear points, you normally want to name them in groups of 3. And because we find out later that any 2 points will always make a line. That's why. So when you're working with it, you always want to name it in 3. So when I look at this, I want to name collinear lines. You're going to say, collinear points, excuse me. Collinear points. Collinear lines don't exist, sorry. Collinear points. You're going to name, say, PTS, so I know you're talking about points. And then you're just going to name any 3 on this line. So do you guys agree with me? I could go H, I, J. Are they on the same line? Yeah, so you have points H, I, and J. Notice I put commas between it this time because I'm representing 3 different points. Could I pick any other the points? Could I go like G, H, and I? Yeah, those would still be on collinear. Now, for non-collinear points, that means they're not going to be what? Not on the same line. And you have to name 3 for this no matter what. Okay, so just know if you're going to talk non-collinear points, there's always going to be 3. So when you do that, those are just points. Which do not lie on the same line. All right, so how do you do this? How do I name non-collinear points? Here's the hint. Think of a triangle. Okay, if you can make a triangle, those are non-collinear points. Always pick 2 of the points on the line. That always makes it easy. So here, I'm going to go points G and H. Now, are G and H on the same line? Okay, but remember, how many do I have to name? So could I go ahead and put F here? The moment I do G, H, and F, I can't connect the points anymore. It bends, right? The moment you do that, you have non-collinear points. But guys, trust me on this, every 2 points I can always make a line through. So that's why you have to name 3. All right, let's keep going. I know this is rough, but we're going to keep on going. All right, coplanar with the same what? Yeah, exactly. So coplanar. So this would be points or lines even, you could say, or shapes. You could do anything like that, which lie on the same plane. All right, so we're going to work with this. Now I have 2 different diagrams here. Do you guys see on diagram W, okay? For diagram W, which I'm going to use for this example here, do you guys see points A, B, C, and D? Are those coplanar points? Because do all of them lie in plane ABC, I guess is what we have to call it, right? They're all in the same one. So for coplanar, like right here, I could literally say, oh, points A, B, C, D. Those are coplanar, okay? So if they lie in the same plane, they're great. You could also say on this one, or you could say line AC is coplanar. I actually didn't say AC, excuse me. Let's change that to AD. Is coplanar, I cannot write today, coplanar to point B. Because they lie in the same plane. Does that make sense? So if they're in the same plane, they're called what? All right, can anyone guess what non-coplanar means? I don't know. Mathematicians aren't real genius, but their names are, right? Just not in the same plane. Exactly. So that's the cool part with this. So when you're doing it, guys, it's just exactly what you think. Points or lines, shapes, etc., not on the same plane. Or not in, if you want to say it the same way. Now, let's use this for a little bit more fun. Let's use diagram Z. How many planes do you guys see there? 2, okay. So you see 2, you guys, you see the blue one, which is plane N, and do you see the kind of the pinkish one that's line T? Is that right? So we have 2 planes that are intersecting each other. That's great. I want to name 4 non-coplanar points in the diagram. You must name at least 4 points to do that. You can't name 3 and be done. And I'll explain a little bit more in a little while. So with this one, if I want to name 4 coplanar points, Here's my hint. Pick 3 that are in the same plane. All right, work with me on this, guys. I'm still going to get some names down. Solomon, help me out. Name 3 points in this one of the 2 planes. It doesn't matter which one. Just give me 3 points. Perfect, because that's what I would have picked. All right, so I have points A, B, C. Do you guys agree with me? Those are all in the blue plane. I can't talk. Plane. Now, I need to pick one that's not there. What would be a point would I put that's not there? E. Because the moment I did that, ABC made that flat surface, but the moment I picked D, did you notice that you can't bend your plane any way to make it do, because a plane's always flat. Does that make sense with those? Okay, excellent. Excellent. All right, let's have a little bit of fun. All right, we're taking the diagram down below. Let's do this with, we're getting there. We're not going to get as far as I want, but we're going to get there. All right, guys, with this one, using diagram A right there, using correct notation, go ahead and do example 2, 3, 4, and 5. I'm not going to give you very long to do it, so think about 30 to 45 seconds. Go. It's okay, look back at your other notes if you need to. Make sure you do all 5 as much as you can. Keep going. So I'm going to do that's the part that you can large tree. That's the all right, just for time, I'm going to give you about 10 more seconds. All right, for time, we got to keep going. All right, it says, on first one, it says, name line T in at least 3 different ways. If I already called it line T, guess what I don't want you calling it? Line T, but is that a valid name for it? Yes. But how many points do I need to name a line? And guys, look at me right now. Everyone hear me. You never use more than 2 points. Ever. Because you're not going to be talking about a line anymore. Correct notation is 2 points. So when you do that, name any 2. Allie, give me 2 points on that line.
G and H.
All right, so she got line GH. All right, help me out. Andrea, what's another one?
HI.
Yep. Hi, back at you. All right. Logan, what you got for me?
IJ.
Thank you. Line IJ. Could I go line JI and be right? Totally. So, notice what I wrote on there. Answers will vary. Yours will look different on this. This is one reason why I don't give an answer key for this, because I don't want everyone to have the same thing, because it can be different. It says name 4 collinear points. So what points are going to be collinear points, guys? That was supposed to be an easy one. Put PTS out in front. Which ones? Name them.
G.
Yeah, G, H, I, and J. Yay! Okay. Now here's one. It says identify 3 non-collinear points. All right, who's got this one for me, do you think? Josh.
Points GHK.
Yeah, pick 2 that are on the line and then pick 1 that's off. You could go like GHF. Do you go IJK? Would that work? Does that make sense? Okay, bless you. All right, example 5. Draw 4 coplanar points A, B, C, D in plane W. I expect you to draw this stuff. I don't expect artists, though. If you're not an artist, this doesn't have to be hard. All you do, draw a parallelogram. It's called plane W, right? So you put the W in a corner. What do I have to do with the rest of those points? Literally put 4 points in here. Use what type of letters when you're naming points? And there you go. Voila. Rough art skills here, people. Tell me. But that's it. That's how easy it is. What do you guys think? Easy schmeezy? It's supposed to be. So don't feel like, where's algebra? That comes later. Don't worry about it. All right, more definitions and notation. We've had this before. A line segment, okay? What is a line segment? It is a part of a line consisting of two endpoints and all points between them. And I do abbreviate points a lot, guys. When you hear line segment, most of you know what I'm talking about. You know it's a part of a line, right? That's a portion of it. It's like you cut a piece off. That's literally what a line segment is. So do me a favor. Let's draw a line segment. Put your 2 points at the end. Da-da-da, a line segment. Woo. I'm brilliant, aren't I? It's good. Guys, here's the cool thing about it. Guess what symbol I'm going to use for a line segment? A line segment. I know you guys are just earth-shattering excited about this. I know. It's so cool. So you name it by its 2 endpoints. And you can't name it by a middle point because I'm not giving you one, but it's always by the 2 endpoints. So it's going to be line segment AB or line segment BA. It doesn't matter which one's first, which one's second, as long as you have the correct symbol over the top. Yes, sir.
Do you have to put the 2 dots like on the end of each?
No, you notice with this one, they just kind of look that way because of my bad handwriting, but it's just, you just put the quick slash over the top. You're good. All right, makes sense. What's an endpoint? A what? A point, right? So an endpoint's just that, a point at the end. And this is just all terminology. Of a segment or the starting point of a ray. Of a ray. Now you guys, what's a ray? That's after we do it, okay? So in this case, just draw an in real quick. Here's C or D. C and D would be called your what? Endpoints. I know, this is just, it's all just terminology because this is the type of stuff, putting on ACT and stuff, you gotta know. So my notation for this would be my 2 endpoints. It's just gonna be points C and D. And that's just a really bad symbol for and. All right. I'm going fast, but got majority of the stuff. Like I said, we're gonna have to finish a little bit of the notes online tonight, but you should be good. Array, okay? No, I don't mean Ray Charles, all right? Array is a part of a line that starts at an endpoint and extends forever in one direction. In one direction. All right, so this is what I mean by that. That's array. Basically, someone says it's half a line. Well, a line never has an end, so can I measure half a line? No. But I have an endpoint. I have another point with it. So for instance, right here, this is RS. I would name that, guess what symbol I'm going to use? It always arrows to the right, though, when you're doing the symbol, okay? You name it by the endpoint first, and then a point going in the direction you want. So that would be ray RS. Like, for instance, if I go this way, let's go MN. Your notation for that would be ray MN. Notice notation, my arrow always goes to the right, but when I see this, this tells you information. It says, oh, look, I start at M right here, but I go which direction? I go towards my N. It's connect the points. It's connect the dots like you did when you was a kid. The names tell you how to connect it. All right, last big definition. Are you guys ready? All right. Opposite rays, okay? They are 2 rays. And then, whoa, we're going to get something done here. This is good. That have a common endpoint and form a line. Now here's where the thing is. They never overlap. They never share points, ever, 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 ever. So how would I draw opposite rays? Are you guys ready for this? You're gonna be just like totally wowed. Okay, I'm gonna draw a ray. Let's call that M and I'm gonna call this one N. How would I draw an opposite ray? Where do I start? Do I start on M or N? M, and I go straight what? The opposite way. Basically, what did I just form? Yep, I just formed a line. So we just formed it. So your opposite rays have to have a common endpoint. So this would be ray MN and ray MW. Because I always name a ray with the endpoint first. So opposite rays will always make what type of figure, guys? A line. Now, listen to me. Ray MN and ray NM are not opposite rays because they start at different spots. Opposite rays always start at the exact same endpoint. All right, so let's draw these and label each of the following. Guys, do this for me real quick. Draw a line segment with endpoints R and S. Go. Okay. R and S. Perfect. Some of you are so much neater than me. I'm jealous. Make sure what type of letters. Capital. Don't forget. Okay, that's pretty good. Draw and label ray AB. Go ahead and do one for me. Ray AB. You just got to make sure the endpoint's what letter? A, right? So it's simple as it is. Don't try to complicate it. Example 8 here. Opposite rays with a common endpoint Q. So draw for me opposite rays with a common endpoint Q. Okay, obviously, could you pick different letters than me? Yeah. All right, guys, how would I name this? How would I name mine? Ray what? Excuse me, I totally did it wrong. QM and what? QN. You guys think you got that? Just remember they can't overlap. Pretty simple. All right, should we try to get a little bit more done in the notes so you don't have to do hardly any video at home? Does that sound good? Should we try one more thing at least? We are cranking this out. Last year it took me an hour and 50 minutes to teach this one lesson. We have right now done this in like 40 minutes. I don't know what you guys are, but you're amazing. So good job. It's not always this bad. Okay, guys, you're doing awesome. All right, first one. What's a postulate, okay? Or the other word they use is called an axiom, all right? A postular axiom is the following. A statement that is accepted as true without proof. Now, I'm going to tell you probably the most important postulate in the Christian faith. God is real. Because if he's not real, does any of our faith matter? Now, there's arguments that you can prove God, and there's arguments that you can't prove God. To me, it comes down to the Holy Spirit. So we're not going to get into that. But really, if we don't believe God is real, does Jesus Christ even matter? Would Wheaton Academy even matter? No. So that's the idea of a postulate. It's unprovable. What would be the unprovable belief of an atheist? God is what? Not real. Not provable, but is that their accepted statement of truth? See how that kind of works? Now, obviously, we're going to do math-wise with this. But that's the kind of the thought process behind it. Now, these numbers, I'm going to tell you right now, mean nothing to me. They just refer to what's in your book, okay? So don't ever memorize these by numbers. Memorize these by words. And here's the first thing I need you to know. It's the following. The very first postulate, any postulate that Euclidean started with was the following. Through any 2 points, there is exactly one line. Another way of saying this is any 2 points determine a line every single time. So think about it. Draw 2 points, draw a line to it through them. I'll call that AB. Is there any way I can draw another line through AB than the one that I already drew? We can't, can you? It's like, no matter what, I get the exact same line every single time. So this is why when we talk about collinear points, 2 always are going to be collinear every single time because of this rule. Let me give you kind of a real world example of this. How many of you ever have taken a shortcut? The shortest distance between 2 things is a what? The 2 things are points, and you're walking straight to them. So that's kind of the example. So this is like the shortest distance thing. How do you do it? It's you're going through a straight line because you take your 2 points and you go right there. So this is like cutting across grass to get there. My mail lady does that. She goes from one house to the next. She doesn't use the sidewalk. She goes straight right there from steps to steps. In the wintertime, I know exactly where she's gone. Like, she goes the shortest distance between 2 points. All right, that's where you got this. So the other way you can say this, though, is any 2 points determine a line. So any 2, you can always connect them, no matter what. All right, till that bell rings, we're going to write the next one down, and then I'll finish the video later. All right, next one. Are you guys ready? Through any 3 non-collinear points, there is exactly one plane. Through any 3 non-collinear points, there's exactly one plane. So think about this for a moment. I know that any 2 points will give me a line, right? The moment I take 1 point off, what shape can I make with those 3 points? Triangle. Guys, that's why they use tripods, because any tripod makes a plane. So think of a tripod for this. So any 3 non-collinear points is always going to give you a unique plane. All right, so I'm going to pause the video here, guys. The last probably, all right, so we're in the middle of the explanation of our second postulate that says through any 3 non-collinear points, there's exactly one plane. So what's the real world example for this? Well, the real world example for this is a tripod. So like on the base of cameras and stuff, we have the tripods because that means no matter how uneven the surface is, as long as I have 3 different solid points to balance on, I'm on a flat plane. So when you're doing this, always think triangles. If you can take the 3 points and make a triangle, you can rest like a piece of paper on it. You can rest a plane on there. All right, so we have one more postulate. That's a really fun one to work with. Again, ignore the numbers. This just means that's a third one that you're working with in this section. The next one says the following. If 2 points lie in a plane, then the line containing those points lies in the plane. So what is that saying? Okay, think about this.
like this. If I have a plane, all right, so we have our rectangle that we're drawing, or a parallelogram. I put X and Y on that plane. What do we know about 2 points? 2 points can give me exactly one line, or any 2 points determine a unique line. Well, where does that line end up being? Exactly on the plane 2. So think of it like the same type of idea. All right, so if I put 2 points on a piece of paper and I draw a line through those points, where's that line located? That line is located on that paper, that plane. So that's why it works. All right, another term we just need to get down so you know it is what an intersection is. And I always like the idea of literally thinking where 2 roads meet. Because where 2 roads meet is their intersection, right? The intersection of 2 roads. Well, that is a location of things. It's a grouping of things. It's where things collide. So here's the formal definition of an intersection. It is the set of all points that 2 or more figures have in common. So now again, think of where 2 roads meet. So here's one road here, here's the other road going this way. What they have in common is where their roads overlap at the intersection. So that's when they use the word intersection. So let's look at the next 2 postulates based off of that as we go. All right, so the next postulate, again, do not worry about the number, says the following. If 2 lines intersect, so if 2 lines meet, then they intersect in exactly 1 point. So think about this. If I have 2 lines, and let's make this other line fun color. Okay, let's make it red. If they intersect, which they would here, they only intersect in 1 location. I can't intersect in 2 because then the lines would bend. Since the lines don't bend, I only have 1 intersection point. So that would be like point P here. So let's call this one line N, this one's line M. So the intersection, no, I can't write intersection all of a sudden, sorry guys. The intersection of lines M and N is point P. Now, 2 lines don't intersect. They don't intersect. They don't share anything in common. But remember, any 2 points, basically when any 2 lines intersect, they're going to intersect in exactly 1 point. They can't intersect in more than 1 point. It's just impossible. All right, last one here, okay? And this one's a little more complicated. It's the following. If 2 planes intersect, all right, so think 2 flat surfaces colliding. Think like your wall and the ceiling, or 2 walls intersecting in a corner, okay? Then they intersect in exactly 1 line. And I always think where 2 walls intersect. Think 2 walls meeting. What would you get? Think about when you look where 2 walls intersect, don't you get like a line or a corner where they intersect? Yeah, that's totally the case. So let me show you how to draw this a little bit. You can draw one kind of going this way. I'm going to draw another one kind of intersecting a little bit differently here. Let's draw one probably coming through, coming forward, going down, and we'll intersect it going this way. And they were going to intersect right here. I'm going to move this one here. All right. Worst drawing I think I've ever made. Redo. You guys don't write this down. All right. Redraw this way. Okay. So we have 1 plane. Okay. That's going to be the plane in red. Plane, whatever you want to call it. And then we're going to have a plane that's blue coming like forward and coming out and kind of intersecting it like this. So we have a line right here. That would be the line of intersection. Okay, so when two planes intersect, because they can't bend, if they're intersecting, they will always intersect at one line. They will share that line in common. Now, when you have three or more walls, you might intersect a line, you might intersect a point. There's more things. But when this was just the key word is two planes intersect, they will always intersect at a line. Now, here's some things you need to remember. Always learn statements for postulates and theorems by words. Forget numbers. Don't ever, always cross out. If you see 115 or something like that on the notes, cross them out and just memorize. If two planes intersect, then they intersect in exactly one line. I want you to memorize that, not the physical numbers behind it. Now, let's see if you guys understand this. Now, I think you guys will look at this and you can see an intersection of two planes. You guys see that you have plane T right here. It's kind of the red one. And you got plane N right here, which is the blue. Okay, so with that, we're going to use those planes to describe some things for us. Now, first things first, it says identify the intersection of line BD. So we're going to have line BD, which is this one right here, and line AC. So connect the points to make line AC. Where do the two lines hit? Well, two lines will intersect if they're intersecting at a point. So what point is that? That would be point C. Excellent. Good job. Okay. Now the next one. I have what is the intersection of plane N? So plane N is the blue one. And plane BCE. So BCE is the same thing as plane T. So this is BCE. Because remember, if I can make a triangle, I make a plane. So it's kind of like coming out at you. So I'm going to take a fun and have a little bit of marker time. Like this would be plane BCE. Okay, because B, C, and E are all on it. And you use three non-collinear points to name a plane. Where do they intersect? Well, if two planes intersect, what does the postulate say? They intersect in exactly one line. So I go over here and I have to write the name of the line. Well, I name any 2 points on the line. So you can name it like line BD, or you could call it line BC. It would be exactly the same thing. All right, last one. Example 11 says sketch two coplanar lines R and S, and they're intersecting at point P. So sketch two coplanar lines R and S intersecting at point P. All right, so I need two coplanar lines. So first of all, I got to put them in the same plane, right? And we're going to put them so they intersect each other. So I have R and S. We use lowercase letters because, again, we're labeling the lines. And intersection at point, so I make it sure I put a dot there to represent a point and put a capital P next to it. All right, so this would help you in your homework. Make sure you're using your notes to help guide you. Correct notation does matter. I do take that in part of my completion grades on here. Guys, come and ask me how to submit homework if you're not sure. I want to make sure we get it all done. And I know it's going to be hard at first, but know that I'm there to help you. All right, guys, you did a great job today in class. Stay safe and out of trouble.